Hi, everyone. Welcome to another episode of Heat Treat Radio. I'm Doug Glenn, your host and also the publisher of Heat Treat Today. Before we get started with today's episode, I just wanted to encourage you to subscribe to a e-newsletter, a monthly e-newsletter that we put out called Heat Treat Shop. It's got a bunch of parts, components, supplies, and materials for manufacturers for their own in-house heat treat, as well as commercial heat treaters. You can do that simply by going to www.heattreattoday.com/subscribe. And that will take you to our subscription page, and just look for Heat Treat Shop on that page. By the way, we're going to be talking about vacuum leak detection today. In the most recent edition of Heat Treat Shop, the lead item was vacuum leak detection equipment from a company you might have heard of, from Pfeiffer Vacuum. So if you get a chance, take a look at it. Again, it's Heat Treat Shop. Please subscribe, and hopefully it'll be satisfactory for you. Now on to the episode. Welcome, everyone, to another episode of Heat Treat Radio. We're going to talk today about leak detection in vacuum, which should be an interesting topic. Happy to have with us today Dave Deiwert, who is a leak detection professional expert, if I might say that. Dave, you think I'm going to give that? You know what? I think I'll let you give our listeners a little bit of background about you and your qualifications in the industry, if you don't mind. But let's do that first, and then we'll jump into some questions about leak detection. So, just a brief history on your background.
Okay, thank you. Yes, I am Dave Deiwert. I've been in leak detection since 1989. I started off my career as a field service engineer, did that for about 10 years. Then moved into sales engineering and did that for probably the second third of my career. And for the last number of years, I've been a product manager and applications manager. Worked with several of the major vacuum and leak detection companies in this world, and thoroughly enjoy what I do and helping others with their leak testing applications.
And now, as of late, you've got your own company, right? Tell us just a bit about that. Name of the company and...
Sure, thank you. Yeah, Tracer Gas Technologies had its birth in September of this year, and my focus will be on providing training and applications assistance to industrial customers and research and development labs and government and university labs.
Yeah, that's great. And then now, do you have what's the best way? Because we'll get this out of the way right up front. What is there a best way for people to get a hold of you? Is there a website or email or phone number?
We are new, still working on the website, but in the meantime, you can reach me on my phone at 765-685-3360 or email me at ddeiwert@gmail.com.
Right, very good. Now, most importantly, Dave recently published an article in the November 2024 issue of Heat Treat Today. Let's see, this article is called Basics of Vacuum Furnace Leak Detection Part 1. It's on page 20 of that edition. So if you want to go to the website, our website, you can read that article. It's in the digital edition, which is under media in our main navigation bar. And Dave, that article, you talked about really 10 tips for vacuum leak detection, and a bunch of them dealing with helium leak detection and
Sure.
using helium to detect those leaks. So we're going to cover some of those today. But what I'd like to know first is, before we get started, is I'm running a vacuum furnace. What are the top 2 or 3 most typical things that happen that tell me I've got a leak? What are the symptoms that we have a vacuum leak?
Now, I've been helping these customers for a number of years, and typically one or two things happen. Either the customer's following the manufacturer of the furnace recommendations to do a periodic, they call leak up test, where they pump the furnace down towards base vacuum. They isolate the pumps and look for the pressure to rise after the pump's been isolated. And if the pressure rises at a faster rate over a test period of time, which might be 10 minutes, then they determine they have a leak that they should be looking for. So it's either during that event that they discover they have a leak that they should be looking for before it becomes a problem with quality, or the problem develops while they're using the furnace and it begins to affect the quality of the product. You start to see a difference in the appearance of the product because there's some type of contaminant gas from atmosphere, water vapor, or maybe their product is sensitive to oxygen and such. So they'll see something with the product. It could be as simple also as, hey, we used to pump down to base pressure for our process. in X amount of time, and it seems like it's taking longer. So one of those few things will get their attention, and they'll
Yeah.
say, okay, let's look for the leaks.
Okay. Yeah. Yeah. Fair enough. So let's assume, because most of the discussion we're going to have today is going to be on helium leak detection, right? Or how you use helium. But let's say you didn't have a helium leak detector. What would be your checklist of things to run down through to try to isolate the source of the leak?
Sure. And my perception is that end users that only have maybe one furnace or two furnaces, they might not have their own leak detector. And if to call for help might be quite a pricey option. So they may try to do some things on their own without the leak detector or help from somebody outside the organization. So the first thing you're going to do is consider where would most leaks typically be on a furnace. Typically, you're going to think of things like the door is open and closed on every cycle of the furnace. So you have a gasket or O-ring type material there that can get worn over time, or maybe while the door is open, something comes to rest on the O-ring, piece of fuzz, hair, slag, metal. Something is there that when they close the door creates a leak path. To look at that in greater detail, get some light, extra light on it, and see if they can determine something there. And they may go ahead and remove that O-ring and just clean up real good. Many might put a light coating of some vacuum grease of some type on that and then reinstall it. Of course, we recommend that you try not to use vacuum grease. That could be a whole nother discussion that we have. A period of concern, many will try that and see if it's helpful to them. But the door seal, the vent valve for the system opens up after every test. So that is another gasket that can get worn or dirty. Things that are another thing would be process gases. If they fill their furnace with backstream with argon or something, those process gas valves can leak past the seat. And
Right.
so each of these things they think about and go through them one at a time and inspect them. And if they're not quite sure what they're seeing, they might go ahead and replace the gasket or seal and then hope that they're successful. And if they continue to not be successful, they ultimately end up calling for help.
Yeah.
So
Yeah. That sounds good. That sounds good. All right, so I want to ask you this one. I'm going to read this one because it was interesting, and I'd like a little further
sure.
explanation, if you don't mind. You say in the first tip in this article that you wrote says it's also the shortest tip, by the way, which I found interesting. You say this quote: "Understand how your leak detector works to the point that you can confirm it is working properly." How is a company supposed to do that? How are they supposed to do that?
If you're going to go the expense of having a leak detector, which many should, and they should understand how does it work properly, how to tell that it's working properly or not before you start spraying helium to look for leaks with this leak detector. Every manufacturer of a leak detector today, and for quite a number of years, has a leak detector to let you know whether or not you're in the test mode or if you're in like a standby mode. If you ever approach somebody's leak testing and the leak detector's in a standby mode and they're over there spraying helium, and you can suggest, "Oh, I bet you haven't found any leaks yet, have you?" And of course, no. And you might want to put your leak detector in test mode. And so, understanding it's in test mode, understanding how to calibrate the leak detector, these are good tools to help your success to finding leaks on the system. So you have to at least be enough familiar with your leak detector to understand its operation and that it's sensitive to helium. And a calibrating procedure helps support that it's sensitive to helium.
Yeah, that makes a lot of sense. Make sure that it's turned on. That's the first thing,
Yep.
right?
Turned on and connected to your system. If you don't have a hose going from the leak detector to the furnace and you're spraying helium, that's also going to be a problem and all
Yeah,
that. So this
yeah,
might sound silly, but sometimes
yep,
people think, hey, this sounds easy. You just spray helium, look for leaks. And they may ask some person who doesn't really have much experience, hey, go over and leak test the furnace. And they may be embarrassed to say that they don't know how to use the leak detector. So they may give it a go. And because they don't understand the leak detector,
right.
they might not be successful.
So,
So
so that actually leads me to my next question because I want to be that guy that doesn't really said, "Oh, what is this? It's a leak detector." How do they work? What do you actually have? Not the internal mechanics of the leak detector himself, but when you're performing a leak detection using a helium leak detector, what how does that process work? Where's the leak detector? Where are you spraying the helium? That type of stuff.
sure, and I've seen in my career people choose a few different points of connection to the furnace, but you'll find in our industry that we teach people that the best place, most optimum, would be to connect a hose from the leak detector to a point in front of the blower if they've got a blower on their system. If they don't have one, it's going to go at a connection point near the inlet of the pump that's
Okay.
pumping on the system. But you want to sample that flow of gases from the furnace towards the pumps And that way you can get a sample to the leak detector as you're spraying the helium. I do add in every class that I teach, when you talk about how does a leak detector work, I do think it's important to at least give enough information to where you have confidence that the leak detector can help you. How is it sensitive to helium and why? These leak detectors, no matter who manufactures it, typically you'll see that there's inside a mass spectrometer that's tuned to the gas mass weight of a helium molecule. And because it's dependent on the mass weight of a helium molecule, not the mass weight of oxygen, nitrogen, argon, whatever, you can be 100% sure that when the leak detector reacts, it's getting helium from somewhere. And I stress that for somebody can get very frustrated looking for leaks. If you don't know for sure that you believe it's only picking up helium, was it reacting to Dave Deiwert's aftershave or cologne or
Yeah.
something else? The fork truck just went by. Was it that? And I can say 100% it's no, it's reacting to helium. And you might be surprised how often in my career somebody said, Dave, the leak detector's reacting. I haven't even started spraying helium yet. And I will tell them helium's coming from somewhere. And it could be the tank of helium that you've rolled up to the furnace is spraying helium that you didn't realize. Maybe the spray gun is, even though the trigger's not pulled, it's still spraying helium. Maybe the regulator's leaking. And if that furnace has got a leak, it's the whole reason why you brought the leak detector over. You're not spraying helium yet, but helium's being sprayed by the tank or the regulator. The leak detector is going to react to the helium regardless of how it got into the system. So that
Right.
can be very frustrating if so let me back up. So if you know beyond a shadow of a doubt that your leak detector will only respond to helium and you haven't sprayed helium yet, you immediately know it's coming from somewhere. So I need to figure out what's going on there. Otherwise, I might spin my wheels looking for a leak while something else is a distraction for me. Does that make sense?
Yes, it does.
Yeah.
Now,
Okay.
but let me ask you this now, because I've never done helium leak detection, and because I'm a publisher of a magazine, so we don't have a lot of helium in this business,
No.
right? But I do have a question. You got this box, we'll call it the helium leak detector. It's got a hose. You connect the hose near as you say, near the blower or someplace close to the pump, the vacuum pump.
Mhm.
And you're I assume that leak that is sampling the air as it's coming towards the pump or towards the blower, correct?
Absolutely.
Then
Mhm.
you're spraying helium on
Mhm.
the outside of the furnace, gently
Yes.
somewhere outside the furnace to see if it's being pulled into the furnace through some hole, and therefore heading towards the pump, correct?
Absolutely. Yes.
Okay, that's
True.
I always wondered. I wasn't ever sure how that worked. What do you do? Spray the helium inside the furnace, then you're checking around the outside of the furnace with the leak detector. I know that sounds silly, but I thought I'd
Yeah.
ask. So the question is, you're sampling the air inside, you're spraying helium on the outside. If that's the case, how is it that if you've got a canister of helium on the outside of the furnace, it's got to be detecting it because it's going from that helium through into the furnace, right?
Mhm. Yep.
Okay.
Yeah. We get into the idea of spraying helium. Where does the helium go when I spray it? When I started my career way back in 1989 as a field service engineer, I was taught that helium rises
Yeah.
because the lightest gas. And so, because if that's true, helium rises, I was taught, as many other people taught, start at the top of the furnace and work your way down and all that. The
Yeah.
problem with teaching that is that helium, remember, there's 5 parts per million helium naturally in the air we breathe.
Yeah.
That's a fact. So if I start spraying helium, I can tell you with 100% assurance that the air currents in the room are going to impact or apply that air movement to that helium. And so the helium, if you can feel the air blowing from your right towards your left, if you feel the air moving that way, and somebody's got a floor fan on, you can be sure that the predominant behavior of helium you're spraying is going to move towards your left and all
Yeah.
that. It's going to dissipate over time and all that, but starting somewhere methodical to spray the helium is important and to not spray too much. Maybe I'm getting ahead of myself for your questions, but
Yeah.
that
No,
answer.
that's okay.
Okay.
That's okay. Yeah. So actually, I did want to ask a little bit about that because in your second and third tip in this article that you did for us, you expressed the need to be patient when doing a leak detection. Just exactly how patient do we need to be, and why do we need to be so patient?
Yeah. Frequently throughout my career, I've run into people who say, I'm not even sure if I've got a leak, so I'm going to spray a lot of helium so I can determine pretty quickly. But if you spray that, the 2 comments I make to people about spray, if you spray that helium like you're trying to dust off the equipment, you've
Yeah.
got so much helium in the air, you're going to definitely find out that the leak detector is going to react to some leak. But now you have to wait, I always say, forever and a day. It's going to feel, could be quite a while. The helium dissipates that you just sprayed all over the system and in the room. before you can continue looking for a leak and all
Right.
that. I always ask this question when I'm teaching a class with people who have been doing leak testing. Say, how do you set your helium spray nozzle? And the ones that have been doing for quite a while will say that they'll get maybe a glass of water, for example, and they'll put the spray nozzle down in the water and adjust the flow to where they get one bubble every 2 to 3 seconds. I see some variation of that, 1 second, 10 seconds,
Okay.
but they'll try to meter it down. Somebody might say, I'll put the nozzle up to my lip and adjust where I can barely feel it and all that. And so those people, I'll say that's a good start. If you put that nozzle in that glass of water and it looks like a Ken and Barbie jacuzzi, you're
Yeah.
spraying way too much helium and
Yeah.
all that. So what should you do? I would meter that down to a very small amount, whether or not it's a bubble every 3 seconds or so, or you can barely feel it your lip, is a good place to start. And because I make the comment about helium doesn't necessarily rise, it can go different directions based on the wind, air currents in the room, pressure and makeup. Eventually somebody will say, where should I start? And I'll say, well, I don't have a problem with you starting at the top of the furnace, working your way down. Be methodical. Some people will start at the leak detector they just hooked up because I might have put a leak in the bellows connection from the leak detector. I might have put the leak in it. So you might start there, make sure the assembly you just did is leak tight. But start somewhere, be methodical as you move across the system. And remember that helium can go up, down, left, back, forward, depending on what the air currents are.
Yeah. 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 That sounds good. Yeah. Yeah. I was actually going to ask you about the air currents because I thought that was an interesting tip that you had made. In fact, I think that's like tip 4 and 5 in this article. I think we're dealing with air currents and things of that sort. So we'll skip over that because I think you've addressed that's
Okay.
important. You mentioned in one other tip, I think it's tip number 6 in this article, you mentioned an interesting thing called a dead stick method. So can you
Yeah.
explain what
Yeah.
that is?
I was glad you actually asked that because I look back at it later. I thought somebody's never done the dead stick method. I don't think I elaborated much at all
Yeah.
on that. But that is a term where you spray the helium away from you in the furnace, just a little squirt, psh, and then stop spraying. And you're going to actually rely on the residual helium that's coming out of the tip of the nozzle for some period of time. In my training classes, I typically have a plastic bottle that has a little right angle nozzle on it. You may have used them back in high school in the lab or whatever, in chemistry or whatever. It might have alcohol in it. I will squirt a little helium in that plastic bottle and then screw the cap on. And that will last me for 2 or 3 days at a trade show or a training event. I don't have to squeeze the bottle. There's enough helium coming out of the nozzle that you can detect leaks. What I'll do to demonstrate, I'll put hair on an O-ring on the cessport leak detector. It's the reason why my receding hairlines.
You've
you
been
know,
doing this way too often.
Yeah. But I can take that nozzle without squeezing the bottle and just move it near the hair that I just put in there, and it will detect it very impressively every single time, at least over the course of a couple days, 2 or 3 days. My point of demoing that is people tend to spray way too much helium. If there's 5 parts per million natural air we breathe, you only need enough delta difference to that so that as you go past where the leak's at, you can see a reaction to the leak detector and pinpoint it. Backtrack to somebody sprays a lot of helium to prove they have a leak. Now I have to wait for a long time for the helium to dissipate. And by the way, it's not just dissipating from the room. You've sprayed a lot of helium that is now feeding that leak. And as it goes through the leak path in the furnace, it expands back out in front of you. It's got to pump away from the furnace too. So it's got to clear the room. And what have you sprayed as it's going through leak path? It's also to clear the system and
Yeah.
go out through the pumps before you get back to baseline so you can continue leak checking. So therefore, if you spray just very small amounts, yeah, you have to get close to where the leak is before you start to get a response. And
Right.
you have less the concern of helium drifting to the opposite side of the furnace and going through a leak path there. Because if you're doing that can really distract you. You think you're near the leak, but it's really on the other side of the furnace because you sprayed way too much helium. And all that.
Yeah.
Yeah, spraying little amounts might make you feel like it's taking longer. But the fact of the matter is when you start to get a reaction to the leak detector, you can be comfortable that you're getting close to where the leak is at.
Yeah. That makes a lot of sense. So if you know you're in a room with air currents in it, let's just
Mhm.
say there's a flow of some sort from left to right.
Mhm.
Is this a make sense to always start downwind, if you will, and then
Mhm.
work your way back across the system?
Yes, very good. Yeah. So if I can feel the floor fan, Joe's got his fan on because keeping him cool and it's blowing over towards where I'm leak testing. And I might say, hey, Joe, could you turn your fan off a little bit while I'm leak testing? He may say, no, it's making me comfortable. I'm
Yeah.
gonna, all right.
People
So I
may
have to
not
deal
be
with
your
that.
friend, but yeah.
So now, okay, I've got to work with, I know that I can feel the air currents moving from my right towards my left. So yeah, starting downwind and working my way up could be
Yeah, work
helpful.
with-
Definitely you want to pay attention to what the air in the room is doing if you can tell. Now it may be a very calm environment and you're not really sure what the air currents are doing. But just be methodical, pick somewhere to start on the furnace. And here's something else I'll say about spraying helium. Once you think you know where the leak is at, every time I put the spray nozzle there, I should get the same response. So I spray the
Okay.
helium, I get a response, I stop spraying, I wait till the leak detector drop back to baseline, and then go back to where I think the leak is. If that's where the leak is, every time I put the probe there, I should get the same response time at the leak detector. If even one time I put the spray gun there and I don't get a response or not near the same, then that's not where the leak is at. You
Yeah.
should be able to be on the shadow of a doubt when you pinpoint the leak.
How often, Dave, do you see more than one leak at a time? Let's say, you isolate a leak, you think you got it, and then you take the gasket off, change the gas, whatever you do, come back, do the test again, dang it, still a leak.
Mhm.
How often does that happen?
I'm going to say probably most of the time. When I was a field service engineer and somebody had called me to come in to help, I almost never found one leak. And that tells me that they were working with one leak that maybe wasn't large enough to affect their quality or
Right.
the cycle time, and they were living with it. And that the day comes where they have a leak that gets their attention or a leak's gotten larger. What can be more challenging if you've got more than one leak and all that. And it's a short-lived celebration when you think you found a leak and then you go to start the process again. Oh, it looks like we still have a leak. That wasn't the one
Yeah.
yeah. So you might make a case for maybe we found this leak, but maybe we should continue looking and
Dude,
see if we
yeah.
can pinpoint another
Yeah.
leak while we're in the leak testing
Yeah.
mode.
Yeah.
So
Good point. All right. Well, besides the fact, this is the last question, I think, Dave. Besides the fact that a helium leak detector can save you all kinds of time. I mean, because typically you can find a leak a lot faster with a helium leak detector than just, process of elimination, let's say. You also mention in that article at least one other tip for saving money regarding the mixture, the mixing of the gas. Can you elaborate on that? And
Yep.
if you could think of
Sure.
it, any other cost savings tips, but at least that one.
Yes. I've already mentioned that people tend to spray way too much helium, and at least until they're sensitive to that concern and cut back on how much they're spraying. But when they buy their tanks of helium, they're buying 100% helium. And remember my comment that you just need enough
Yep.
delta increase of helium that you're applying to where the leak's at to be able to pinpoint it. So the possibility that you could buy your tanks of helium at a lesser percentage, maybe 25% helium and 75% nitrogen, and that would help you save on some helium and help your efforts not be spraying too much helium.
Right.
That might make people nervous. People have not been saying that in this industry. And so they can make them nervous. I don't know, Dave. We've never done that before. I've never heard anybody else say that before. So I suggest if you are going through a lot of helium, yes, we could cut down how much helium we are spraying. Maybe we could save some significant money, especially these larger facilities with many furnaces and so forth. Give it a try. Buy one tank of it with a mixed gas and pick something that you're comfortable trying. Will it be 25 or 50% helium? And buy one bottle. And the next time you leak test your furnace, you find a leak, then roll the percentage of gas, maybe you already got right there, then try to look at that leak with the lower percentage helium and prove it to yourself if using a lower percentage of helium is going to save you money.
Yeah. Yeah. So you're suggesting to get themselves comfortable with it, they use their 100% until they find the leak and then try the mixed gas, the lower percentage.
Yeah. And when they to prove to themselves they can still have the capability to find leaks like that, then they could save a little money. Plus the added benefit of you're not spraying so much helium and having to wait as long for the area to clear up before you can start spraying again to continue pinpoint.
Which would save you time, which would save you additional time. So that's great.
Yeah.
All right, Dave, thank you very much. I think that sounds great. Do we miss anything? Is there anything else that you think is worth saying here before we wrap up?
Maybe only that if you know you've got a leak in your system, it failed the leak up test or quality, or whatever, and you sprayed helium around the entire system, you can't find any leaks, then you're probably looking at an internal leak, most likely past the seat of a valve, or maybe you've got a vent valve that's leaking past the seat, but your plumbing to that vent valve maybe goes out of the building, so you don't really have an easy access to spray helium past that. But for example, with an argon valve, you may need to disconnect the argon supply from that valve so you can get access to that side of the valve to spray helium to see if you can detect a leak past the seat of that valve.
Gotcha.
So,
Gotcha. All right. Very good. Very good. Dave, thanks very much. I appreciate it. I'm sure we'll be talking again. I know vacuum leak detection's an important thing. And by the way, we're looking forward to part 2 of that article whenever it comes out.
Okay. Very good. Appreciate it.
Well, I hope you enjoyed listening to that episode with Dave Deiwert. Thanks for listening. We also want to thank Dave. If you'd like to get in touch with Dave, we should have his contact information up on the screen as we speak. But if not, or if you're only listening, feel free to email me at doug@heattreattoday.com, and I'll be sure to put you in touch with Dave. If you would please give Heat Treat Radio a 5-star review or a like wherever you listen to your podcasts, on Spotify, Apple Podcasts, SoundCloud, iHeartRadio, Podbean, wherever. Just give us a 5-star review. It'll help others find our podcast. And let us know if you want to hear about something specific on Heat Treat Radio. We're very happy to take suggestions on content, and you can email those suggestions to me at doug@heattreattoday.com. And don't forget about subscribing to Heat Treat Shop, a monthly e-newsletter where you can find information about parts, components, supplies, and services for manufacturers with their own in-house heat treat departments. You can subscribe at www.heattreattoday.com/subscribe, and then just look down through the list of e-newsletters for Heat Treat Shop. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. Thanks again for listening. I'm your host, Doug Glenn.